Welcome to the webinar series on mainstreaming urban climate action, which includes 4 short webinars on concepts related to climate action in cities. This series has been developed by Terry in collaboration with the European Union International Urban Cooperation Programme in India. This webinar Module 1, titled Impact of Climate Change on Cities, focuses on the conceptual understanding of climate change, its causes, linkages, and sectoral impact on urban areas. So let's begin. Over the past few decades, global climate is changing rapidly, and human activities are being attributed as the primary reasons for it. In India, where 1 in every 7 person on the planet lives, almost 1 million people are at risk from the impacts of climate change. But first, we need to understand what climate really is. Climate can be defined as the long-term average of weather in a specific region measured over several decades. It describes the weather conditions that are expected in a region at a particular time of the year, and it has various indicators such as temperature and precipitation. Climate change describes a change in the averaged weather conditions in a region over a long period of time. Even though climate change occurs naturally over the course of time, in the past few decades, it has been changing rapidly due to human activities. Evidences such as increase in sea levels, changes in surface temperatures, decrease in snow covers, and other phenomena such as erratic rainfall patterns indicate towards this rapid climate change. Climate change-induced events such as floods and heat waves can have costly impacts on basic services, infrastructure, housing, and the health of cities. At the same time, cities are a key contributor to climate change, as urban activities are major sources of greenhouse gas emissions that add to global warming. Greenhouse gas emissions, or GHG emissions, generated especially by human activities, are changing the natural greenhouse effect, leading to the rapid climate change. These emissions cause the atmosphere to trap more heat than it used to, leading to global warming. Few examples of anthropogenic sources of emissions include carbon dioxide emissions from the burning of fossil fuels and deforestation, as well as methane from landfills and waste disposal. GHG emissions can be represented by the type of gas and by the allocation in economic sectors. Globally, 65% of the total GHG emissions comprises of carbon dioxide produced from burning of fossil fuels. Power and heat generation account for 25%, whereas the agriculture and forestry account for 24% of GHG emissions. According to the Intergovernmental Panel on Climate Change, or the IPCC, human activities are estimated to have caused approximately 1 degree Celsius of global warming above pre-industrial levels. If GHGs continue to increase at the current rate, global warming is likely to reach 1.5 degrees by 2050. 1.6 million people living in over 970 cities globally will be regularly exposed to extreme high temperatures by the year 2050, including cities such as Bengaluru, Chennai, Delhi, Jaipur, and Kolkata. Damage and fatalities due to extreme climate events like increased intensity of rainfall, storm surges resulting in floods, and droughts are key areas of concern for many nations and cities.
Similar to global climate change, the same kind of trends of increasing extremes and increasing temperature and varied precipitation is seen over India as well. If you see the temperature plots or anomaly plots over India for the long time series, you see the last few decades have been extreme warm, which clearly shows the rising warming trends over India. If you talk of rainfall trends, it does not show any clear rising trend or decreasing trend. However, year-to-year variations, year-to-year variability of rainfall is seen over Indian domain. If we specifically see about extremes over India, the temperature extremes and the rainfall extremes have also shown a real increase in the last 100 years and specifically a larger increase in the last 30 years of history. The same kind of trends are seen over flooding events over India as well. If you see, around 50% of all the smart cities are currently situated in districts which have larger than national mean for flood events. Now this becomes very important for infrastructure and development sector. The more the flood events will occur over a city or over a district, the more important it is for the planners to take that into considerations in their planning activities.
To prepare cities for climate change, we need to first evaluate the potential tangible impacts and quantify the risks. So we need to understand some key terminologies associated with climate change and their relationship with each other. A hazard is an event or process, such as floods and storms, that may cause harm to life and property, as well as cause social and economic disruption. Vulnerability relates to the factors that increase the susceptibility of an individual, a community, or a system to the impacts of hazards. A broad set of physical or socio-economic factors, such as the type of housing, income levels, social status, and the gender of urban populations, determine the vulnerability. Exposure indicates the tangible number of persons, infrastructure facilities, houses, industries, or other assets that are located in hazard-prone areas. And risk is the potential loss of life, injury, or damage to assets that can occur due to a hazard based on the exposure and vulnerability of the system, society, or a community. Thus, the risk of climate-related impacts in cities results from the interaction of climate-related hazards with the vulnerability and exposure of human and natural systems.
Cities face grave risks from sea level rise, urban flooding, water stress, loss of biodiversity, and other climate change impacts. Climatic events in the form of extreme disasters also affect critical infrastructure in cities like roads, railways, water supply lines, and electricity supply.
In urban settings, climate-related disruptions of services in one infrastructure will almost always result in disruptions in one or more infrastructure systems. For example, electricity is required in the functioning of multiple sectors. If the electrical grid fails, it will affect transportation systems, water treatment, healthcare, and the well-being of citizens. Thus, climate change impacts are cross-sectoral. The Mumbai floods of 2005 provide a comprehensive and dire picture of the impacts of extreme climatic events. According to The Guardian, on 26 July 2005, Mumbai city received a record 944 millimeters of rainfall in 24 hours, which is the average amount for the entire season and was the highest in 100 years. Reportedly, 1,493 people died and more than 14,000 homes were destroyed. And the city incurred losses amounting to almost 1.3 billion euros. Similar losses have been incurred in other Indian cities such as Chennai and Kochi due to climate change.
Climate change poses distinct developmental challenges to these cities owing to the rapid population growth, high levels of inequality, and of course the inability of critical infrastructure and services to adapt to the projected climatic changes. Informal settlements in particular are spaces where these challenges manifest in extreme forms. Climate change affects access to services in these informal settlements, including water supply, electricity, sanitation, employment opportunities, and many other developmental indicators.
Similar to floods, heat waves also have impacts on sectors such as health, infrastructure, and economy. Serious challenges arise when extreme heat events linger for prolonged periods, as closing down of activities for multiple weeks is often not an option. Especially in Indian cities, where majority of individuals working in unorganized and informal sectors have to earn their daily livelihood. So on the advent of long spells of heat waves, they either have to stay indoors or compromise their sources of income, or run the risk of succumbing to heat wave related illness upon continuing to work.
Urban development that is blind to climatic risks is bound to increase exposure of cities to climatic hazards. These exposures will also be differentially determined among vulnerable population groups, including women, children, migrant workers, and indigenous groups, among others. As the Global Commission on Adaptation rightly reiterates, climate action in cities should also be considered as windows of opportunity to address structural inequalities, while cities themselves remain as centers of opportunity for the people and economic powerhouses for nations.